Okay, we're going to use this Superman image to to demonstrate something. And I know you've done this before, but as we looked at those pairs of figures that were in proportion to one another or not in proportion to one another, we were using a very informal definition. And like I said, we're going to create a more precise definition of what same shape, same size, or similar really means mathematically. Because pair H, which were those two curves, are actually mathematically in proportion or similar to one another. They're both parabolas, and all parabolas will be similar to one another, but they certainly don't look the same shape. And so we need a better definition. When you think about things that are being not similar, probably what you were using was sort of this definition of similar being in proportion. So you've done this where you've put a photo in a document and you shrink it down, and if you pull at the corner, you end up with a picture of Superman that is proportionate to the original one. But if I stretch it this way, I'm going to get something very different than my original Superman. Let's get back to R now. I'm not quite back there yet. I've got to stretch it out. So that's pretty close to what we started with right here. If we shrink him down this way, we're going to get a really short and wide picture that is not in proportion or would not be similar. Okay, so that's kind of fun to play with and thinking of how do we keep the whole thing. And with video editing or picture editing, it's going to be to pull at the corners instead of at the sides. Okay, so this is kind of fun to play with. All right, let's move on to a discussion of what a precise definition of similarity would look like.